Hello and welcome Math 30-1 to Lesson 5 of Transformations. Now before we get started on today's lesson, I have a little secret for you, okay? It's about the transformation of y is equal to the function of x to y is equal to the function of b of x, okay? So now, if I replace x with bx, can you figure out what that b does? Well, I have some things here to help you figure it out. So let's take a look at here. Here are my two equations, okay? Notice x is getting replaced with x over 3 for the red, and for the blue, 3x. And these are what their graphs look like. So there's my original graph, x squared. Here's my red graph, okay, if I replace x with x over 3. And here is my blue graph. Maybe now you have an idea of what b is doing to the graph. Let's take a look at the next one here. I'll make that a bit bigger so it's easier to see. So we have x is being replaced with here by negative, or by 0.1, or by 10. This is the same as 1 over 10. So x over 10 would be the same there. Let's move this over. Make it something that looks like that. Look how narrow in this blue is. Now if I look at this, my vertex is still the same point, and it's below the x-axis. Okay, let's take a look at my next one. So here's my graph for those. Those are my three equations, and here are my graphs. Okay, notice once again, my blue is very close to the y-axis. My red is farther away from the y-axis, and my black is right there in the middle, which is my original. Okay, here x is replaced with 3x. Here x is replaced with x over 3. Let's take a look at my last one now. Okay, those are my equations. And this is what we have. Okay, well, if we look here, my vertex wasn't on for this one here. My vertex was not on the y-axis. And look what happens to the vertex when we replace x with 2. I went closer to the y-axis. When I replaced x with 0.5, we went farther away from the y-axis. Those are both kind of interesting things, aren't they? So right now, I want you to see if you figured out what my pattern is. Okay? Now look at this here. Maybe you could answer this question here on the bottom to help you solve my patterns. Okay? So it says, what happens to b if b is greater than 1? All the ones where b is greater than 1 are blue. Okay, those are my blue graphs. Go back. My blue graphs are when b is greater than 1. What is happening to the graph? What happens if b is between 0 and 1? Let's take a look at that. What happens when b is between 0 and 1? Look at my red graphs. So what is happening in this set of graphing here? What does my b value do? I want you right now to pause and see if you could solve it. And once you've done solving it, resume the video. Okay, so now I have a second secret for you. It's what does a do? So a is outside of the function. So in other words, y kind of relates to a, doesn't it? Okay? So y over a, or 1 over ay, is the same thing as a over there. I multiply both sides by a. Alright? So, let's see if we can figure it out. So here's my first equations. This is what the graph looks like. Okay? Here's my second set of equations. Okay, look, we have my black as my original. So here, everything is multiplied by 5, right? The x squared is multiplied by 5, and the negative 3 is multiplied by 5. Okay? Then everything's multiplied by 0.2. So it's multiplying everything in the function by 0.2. 0.2, and then the 3 is multiplied by 0.2. We end up getting something like that there. Okay? And then here's my last one. Okay, everything's multiplied by 2, everything's multiplied by 1/2. What happens? We get something that looks like that. This one here is the most interesting. look what happens right here. My y-intercept, it's not like the one before. When we had x minus 3 up here, look what happened to the x minus 3 up here. My vertex is still at the same point. But now on this one here, my vertex is not. So that's interesting. So now, what happens to our graph if a is greater than 1? So look at all the blue ones. What happens if a is greater than 1? What is happening? Okay, look at the vertex here. Or look at my y-intercept there. It is at 5. Now my y-intercept has changed. It's changed there. Let's look at this one here. The y-intercepts here are all the same for that equation. Y-intercepts do not change really in this. Okay? So what is happening? What does a do when a is greater than 1? What happens when a is between 0 and 1? I want you to see if you could solve those and write down what kind of pattern you think is happening. So as you guessed, we are doing in today's lesson reflections about the x or y axis. Okay, so we're going to go straight ahead and sum up everything we learned, or hopefully you discovered in our discovery, and then a little bit more. So if we're looking at a here, a is right there. That has nothing to do with x. It's really like saying 1 over a, y is equal to f of x, right? So y is being replaced with 1 over a. So as soon as y, we're dealing with y, this is a vertical. Vertically stretch, so stretch vertically by a factor of a about the x-axis. Okay? Let's take a look at the second one. It says a is greater than 0. Once again, a is being used. A is referring to y. Anything dealing with y is vertical. So this is a vertically stretched vertically by a factor of a about the x-axis. The x-axis is right here. We have to stretch everything vertically about the x-axis. The next one here, we're looking at the graph of f of x, where a is less than 0. Well, now, if I look at that, and we're going to relate this to last class when we have reflections. So this must be negative. That means there's a negative outside there, right? As soon as there's a negative outside, we learned last class that it is going to be a reflection in the x-axis. So it's reflected in the x-axis, okay? And stretched vertically by a factor of a. So we do the reflection first, and then we stretch it vertically, okay? Or we stretch it, then we do the reverse. So if we were to graph this, I would first stretch vertically and then reflect it, okay? Now, the next one here, we're looking at b. Now b, x is replaced with b of x. So we're dealing with x. So it is stretched horizontally since everything x has to do with the horizontal. Whoops, we're looking at this one here. Okay, now horizontally, if we're stretching horizontally, we're stretching from this axis right here, this y-axis. Okay, so by a factor of 1 over a about the y-axis. Oops, sorry, 1 over b about the y-axis. Why is it 1 over b? Because if we look before, if it was between 0 and 1, we got bigger, right? If it was between 1 and higher, we got smaller. So it was actually by 1 over b. It's by 1 over b exactly. So let's take a look at this one here. When b is greater than 1, once again, it's b, so it's horizontal. Okay, by a factor of 1 over b, okay? And that is about the y-axis. Here are some examples that we looked at on that kind of relate to it. If I go back here, okay, and we're looking at this here, we look at it, look at this. This is all multiplied by 2, right? So x is replaced with 2x. And there is my original. Now it's only half as far. So that's 1 over 2, the distance away. Okay, now here we have 0.5x, so it goes from 4 to 8. So it's twice as far away. Everything goes twice as far away. So that's 1 over 2 or 2 over 1. So it's the reciprocal. And that just shows it from doing those there. Okay? So now, what about when b is negative? Well, as soon as we said we had a negative in front of the x, we reflect it in the y-axis. Okay? And then we stretch it horizontally about the y-axis, okay, by a factor of b. Okay? Does that make sense? So right here is a good summary of everything we're going to be looking at. I strongly recommend highlighting. But we're going to continue on to class example number 1. It says, write the replacement for x or y and write the equation of the image of y is equal to f of x after each transformation. So A here says a horizontal stretch by a factor of about 6 about the y-axis. So if we remember, we're having this is our b. So x gets replaced with, and it's a factor of 6, 1 over 6 x. Okay? So we end up getting y is equal to f 1 over 6 x. Or y is equal to f of x over 6. If we want to simplify that, and that's what we end up getting. Now the next one here says a vertical stretch by a factor of 1/5. Okay? So then y, as soon as we're looking at vertical, we're looking at y. It's getting replaced with 5y. So then we're going to end up getting 5y is equal to f of x, which then gives us y is equal to 1 over 5 f of x. Okay, so that's what we end up getting. Next it says a reflection in the x-axis and a vertical stretch about the x-axis by a factor of 3. All right? So x-axis, vertical, so then y is being replaced with negative 1 over 3y. Okay? Because the negative means there's a reflection. And 1 over 3 is our factor. And it's vertical, so we're looking at the y. Okay? So this ends up giving me, we have negative 1 over 3y is equal to f of x. Now this translates to y is equal to negative 3 f of x. Because I just multiplied both sides here by negative 3, negative 3. Okay? Just like for this one, we divide both sides by 5, divide by 5, or multiply by 1 over 5 to get rid of it. Okay? Whichever way you want. Think about it. Okay? So let's take a look at D. D says a horizontal stretch about the y-axis by factor of 1, 2, and a vertical stretch about the x-axis by factor of 1 over 4. So first, we want a horizontal about the y-axis. So that's x. Goes to, of 1 over 2, to 2x. Okay? So we end up getting y is equal to f of 2x. Now we have a vertical stretch of 1 over 4. So we have y now goes to 1 over 4y. So we end up getting 1 over 4y is equal to f of 2x. This can be simplified, multiply both sides by 4, multiply by 4. We end up getting y is equal to 4f of 2x. Okay? So that's all we have to do. Number 3 we look at says, number 2 it says, how does the graph 3y is equal to f of x compare with the graph y is equal to f of x? Okay, well in this, y went to 3y. Okay, so basically we have y is equal to 1 over 3 f of x. So that our y is replaced with 3y, we have a vertical stretch by a factor of 1 over 3. By a factor of 1 over 3 about the x-axis. Okay, that's it. Now the second one here says, what happens to the graph of the function if of y is equal to f of x if you make the following changes? We replace x with 4x. Well, this one is going to be a horizontal stretch of a factor of 1 over 4. Or horizontal stretch of a factor of about the y-axis. Okay. Next one is y is replaced with 1 over 3. This is a vertical, because it's now y, so it's automatically vertical. Stretch about the y-axis, or sorry, about the x-axis by a factor of 3. Okay? And now the next one, it says y is replaced with 6y and x is replaced with 1 over 3. So then first of all we have a vertical stretch by a factor of 1 over 6 about the y-axis, or sorry, about the x-axis, and a horizontal stretch of 3 about the y-axis. Okay? Now number 4 looks at, and we want to sketch this graph. So here's f of x, we're sketching this. So first of all, x is transferred to 2x. Well, what does this mean? I'm looking at the negative second, because I go by stinky rotten tomatoes. Stretches, then reflections, and then we do translations. So I'm going to go 2x, that is a factor, horizontal, factor of 1 over 2. So everything's half as far away. So this right here is going to end up being there, right? This here is going to only be there. This point here is going to be 3 away. Okay? What about this point here is going to be 2.5. This point here is going to be 3 away. So my new shift will look like this. That's right on of 1/2 about the y-axis. Okay? Now the next one is x must go to negative x. So now we have this and we're putting it negative. So now I'm going to reflect this about the x-axis, or about the y-axis. So now it is reflect about the y-axis. So all positive x's turn negative. So this point, I'm going to do this in pen, so my final's in pen. So we end up getting here, this goes to this side, so that there will go right here. Okay, this point here will go, it's 1, 2, so we have to go 1, 2, it's going to be there. And this point stays. Now this point here is going to go 2 over there. Okay, and this point here is going to have to, or sorry, this point here is going to have to go all the way over here. And my next one is this point here is going to go over 3, 1, 2, 3 there. So we're just going to connect everything together here, and it's going to look something like that. And that's everything. Hopefully you understood.